Hi, I'm Arha Gandhi, and this is my Physics Lab 1. Here's my introduction. The purpose of this lab is to evaluate the motion of a specific object that is moving at the same speed without changing direction. To do this, we recorded a video and analyzed it in the Tracker application. The models that were used in this experiment were charts from Tracker and a GlowStrict program that uses the initial velocity and net force to analyze the changed position of the object. The physics principles that were used in this lab were the momentum principle, which is Newton's second law, and that is F net equals change in momentum over change in time. The velocity update formula was also used, which is Vf equals Vi plus F net over m times change in time. This formula can be derived from the momentum principle. The position update formula was also used, which is Rf equals Ri plus V average times change in time. All of these are really related and all of these are used in several different ways, but the most important principle that were used in this lab is the momentum principle. Here's a preview of my results. You can see that while the model and the graph are very, very similar, the predicted is a little bit different than the actual because there's no way to minimize all outside forces in the physics lab. So here are the models that I got. So you can see a close-up of the graph that we used, and that was the overall model. You can see the x position predicted and the x actual and the slight differences between both. Here's the experiment. So we recorded a video of a marker with constant motion. Use the length of the board to calibrate the Tracker app. After this, we tracked the motion of the marker using the track function, and then we compared it to a model that we had prepared in GlowScript. To prepare this model, we used the following information. Since velocity is constant, and that was what we were given, F net is equal to 0. This can be found through basic principles of physics. We also know that Vf equals Vi because F net equals 0, and this is based on the velocity update formula by plugging in values. Because Vf equals Vi, the average velocity is equal to V final, and that's something that you just learn. To find average velocity, use the change in position over change in time formula using the initial positions from the data given. After finding average velocity, we can use the position update formula to then update position. So here's the code that I had, and here's the graph that was drawn. And then here's the discussion of the information. So the model is different than the real data for several reasons. Firstly, velocity can't be constant in real life because there's no way to minimize forces such as friction in real life. Secondly, starting and ending positions are slightly off. Thirdly, the Tracker has human error as well, and there may have been a few clicks that could have been a little bit off. And even so, the model and data are accurate enough representations of the data because the slopes are relatively linear and it matches the assumption that velocity is constant. So what if? So if the axes were switched, we would get the same results, but the vector placement would be different. So if we were analyzing the motion on the y-axis, then you would have a 0 and a y value and a 0, and that would be your velocity and your position. But if you were analyzing it on the x-axis, then you would have a 0 and then, or you would have an x value and then a 0 and then your 0, and that would be the position that you get. However, if we had x and y in different positions and you had a negative x, it'd be different because the position would be moving negatively, so it would be a negative version of your position. And no, it's not possible for us to add up every single one of the forces that acts upon the object. There are often infinitely many sources acting on an object, and because of human error, with the tools that we're given, it's not possible to calculate every single one of the forces that there are in the world. Conclusions. So reasons for error. Human error is a pretty big reason for error. We might have slightly measured the board off, and Tracker might not have accurately measured the position. We also could have started at a different position, and it's really difficult to have an object with constant velocity and 0 net force acting on it in real life. Conclusion. Overall, the model is similar to the actual graph with slight differences because of human error as well as not an accurate velocity, and the fundamental physics principles that were used were the momentum principle and the position update formula.